let's say, give me an animal. Who? Oh. You want it with 2 T's?
Yeah.
Or just 1 T? Right, it's a former student, right?
What comes in the food?
Oh. Give me a number.
57.
Give me a form of transportation.
Train.
Segway.
No, you segue.
No, sorry. Too late. Oh.
What's it though?
Yes.
It is mushroom.
Yes.
How do you know the Matrubis? Saturday school?
Alright, so what's that?
Hi.
AB.
That's the velocity of A relative to B. What's that?
BC.
It's velocity of B relative to C. And I'm looking for what? Time. And how am I going to find the time? It's going to be through the velocity of AC because I have a distance that's relative to C. Alright. So, I know that the velocity of A relative to B, when added as a vector to the velocity of B relative to C, will give me the velocity of A relative to C. Is that what I'm after?
Well, you have to find it first.
Yes, it's going to help me get there, right? I have to get that to get where I'm heading.
Yeah.
So I'm going to add those 2 vectors. AB is 8 meters per second at 57 degrees. And I'm going to add that to 2 meters per second at 19 degrees. And I'm going to move this just a second. Come on. Well, when it's working, it's pretty cool. then what I need then is velocity A relative to C, which is those two added together. So, good. I'm going to take this guy, 8 meters per second, and I'm going to say, hey, that's the same thing as going to the right and up. How much? Well, this one right here, we'll call X, this we'll call Y. Cosine of 57 degrees, because I have the hypotenuse and I'm looking for the adjacent, is X over 8. Therefore, X is 4.4. And then sine of 57 degrees is Y over 8. Therefore, Y is 7. Then I'm going to do the same thing with the blue. I'm going to say the blue is the same thing as saying it's moving to the right and up at the same time. Call that blue X and blue Y. So cosine of 19 degrees, X over 2, which is 1.9. And sine of 19 degrees is Y over 2, so Y is 0.7. So the green is really these two. I'm going to draw it up just to get it out of the way of the other work I've done. You see how it's the same as if I'd gone down? So the horizontal is 4.4 plus 1.9, so it's 6.3. And the vertical is 7.7. So VAC is 9.9 meters per second at which one? Which color X and Y? Red, blue, or green? Yes. That's right. The green X is the red X plus the blue X, and the green Y is the red Y plus the blue Y. And then I know that VAC then, the magnitude of VAC squared is just 7.7 squared plus 6.3 squared. So I do the Pythagorean theorem to get 9.9 meters per second. And then we'll call this angle theta. And therefore tangent of theta is 7.7 over 6.3. So theta is how much? 39.
Wait, why are you trying to find the angle?
Oh, I don't need it, do I? Because of the way the question was worded? But just out of habit, I guess. To find the angle, you do tan -1 of 51 degrees. It doesn't matter. You do inverse tan of the opposite, which is 7.7, divided by the adjacent, which is 6.3. And again, I don't need the direction for this particular problem, but I do in most of the problems we're working, so that's why. Yeah. The 9.9 is right here, 7.7 squared plus 6.3 squared and the square root of that. I used the Pythagorean theorem on this triangle to get the hypotenuse. Okay? Now, again, I don't need the direction because what was the original question? Time given a distance relative to the ground. And so to find that, I know that, let's see, let's go orange. So velocity is distance over time, therefore time is distance over velocity, or in this case speed. And I know it's going to go 13 meters at the rate of, I got a lot of velocities up here. Which one do I use? 9.9, because that's the one that's relative to the ground. So 13 divided by 9.9, 1.3 seconds. Okay? Yeah.
Is this the hardest thing to do?
For most students, yes, they feel like this is about the hardest thing to do.